Let's work on part C now. So we have the derivative of this entire expression over here, which is a multiplication. So let's write it over here below and start solving. In part C, we have y times ln of y squared derivative with respect to y. So what do we have here? We have a product, meaning that we're going to use our product rule. So we differentiate term by term. Y derivative times the other term. We have y derivative times ln of y squared, and then plus we have y multiplied with the derivative of the second term. So we will have ln of y squared derivative with respect to y. Let me just write these indexes so that we know what we're differentiating with respect with. Now y derivative with respect to y, that's just going to be 1. So 1 times ln of y squared plus, what do we have on the other side? We have y as our constant. And what's the derivative of ln of y squared? Well, we're going to use the logarithmic property, which is 1 divided by y squared, but then, because this is an expression of y, we have to use the chain rule as well. So we also have to differentiate y squared with respect to y. Okay, let's keep solving. So we have now ln of y squared plus y, and y from here cancels out, so we have y and y goes away. What are we left with? We're left with now the following: 1 divided by y times the derivative of y squared with respect to y is just going to be 2 times y. Again, y and y cancels out, so y and y goes away. What are we left as a result? Ln of y squared plus 2. That's going to be our answer. Okay, we did that. We have one more. So this one is related with the quotient rule. What do we have in part D? The derivative of theta squared over 2 theta plus 1. So let's do that as well. Theta squared, so theta squared divided by 2 theta plus 1. We're differentiating this with respect to theta. Okay, so we're going to use the quotient rule because we're differentiating a division. Now we're going to differentiate the first term, theta squared derivative with respect to theta, multiplied with the second term with a denominator which is 2 theta plus 1. Now minus, we're going to subtract the first term, theta squared, multiplied with the derivative of the denominator, which is 2 theta plus 1, derivative with respect to theta, all of it divided by the denominator to the power of 2. So 2 theta plus 1 to the power of 2. Okay, let's keep going. What's theta squared? Theta squared derivative, that's 2 theta multiplied with the second term, which is 2 theta plus 1, minus, what do we have on the other side? We have theta squared, so we have theta squared times 2 theta plus 1 derivative with respect to theta, that's just going to be 2 over 2 theta plus 1 to the power of 2. Okay, we got that. Let's just write it in a more simple way now. What can we do? We can open the brackets over here. We can multiply 2 theta with 2 theta, so that becomes 4 theta squared, and then 2 theta times 1, so plus 2 theta, and then minus the other term, minus 2 theta squared from here, so 2 theta squared divided by 2 theta plus 1 to the power of 2. What else can we do? We can subtract these terms. 4 theta squared minus 2 theta squared is just going to be 2 theta squared plus 2 theta divided by 2 theta plus 1 to the power of 2, and that would be it, and we are done.